Hello everyone! In this lesson, we will learn the base knowledge of the DeviceNet communications bus together and focus on explaining the back-of DeviceNet I/O model. First, let's learn about DeviceNet. DeviceNet is a field bus system based on the CAN bus, which is widely used for data exchange between automated devices. It allows devices from different manufacturers to share the same network and is used to connect various devices, such as PLC, actuators, industry controllers, systems, etc., thus enabling transparent communications between devices. Next, please answer this question. Which bus systems is DeviceNet Bus developed from? A. Internet. B. Profibus. C. CAN. D. Modbus. I will give you 5 seconds to think, and we will announce the answers after 5 seconds. The answer to these questions is C. Did everyone choose the right answer? Okay, let's continue. The characteristic of the DeviceNet bus mainly includes 6 points, which are: Point 1. The DeviceNet bus only supports up to 64 nodes. Point 2. The network structure is a bus that connects devices through tapping cables. Point 3. A 121 ohm terminating resistor is used on either side of the bus. Point 4. The bus network can use bridges, repeaters, gateways, and routers. Point 5. The bus supports different modes, such as master-slave, peer-to-peer, and multi-master, for data transmissions within the network. Point 6. Devices in the DeviceNet network can be connected or removed from the network while powered on. Next, please answer this question regarding the characteristic of the DeviceNet bus. Which of the following descriptions is incorrect? A. Supports up to 64 nodes. B. The network structures connects devices through serial cables. C. A 121 ohm terminating resistor is used on either side of the bus. D. Supports data transmissions in different nodes, such as master-slave, peer-to-peer, and multi-master. I will give you 5 seconds to think, and we will announce the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? The correct description should be: connects devices through tapping cables. Next, let's introduce the DeviceNet devices. The DeviceNet devices used in this course is the back-of I/O model, as shown in the figure. This model is composed of a bus coupled and multiple terminal modules. According to the picture, please answer this question. What are the 2 main parts of the back-of DeviceNet I/O model? A. Bus coupled and powered model. B. Bus coupled and digital input model. C. Bus coupled and multiple terminal models. D. Digital input model and output model. I will give you 5 seconds to think, and we will announce the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. First of all, let's look at the bus couple. The BK5250 is a compact bus coupler for DeviceNet, which can automatically detect the baud rate. There are 2 address selection switches for address assessment, and the orange connectors is a 5-pin connectors for field bus connection. Moreover, this coupler can automatically identify the terminal models connected behind it and automatically assigns the input and output to the bytes in the process image area. The KL1408 is an 8-channel digital input terminal model. Each channel has an LED to indicate its signal state, and the reference ground for all inputs is the 0-volt powered contact. We also use the KL1A09 16-channel digital input terminal model and the KL2A09 16-channel digital output terminal model. Okay, everyone, let's continue to explain the analog input and output models. The KL3064 is a 4-channel analog input terminal model, and its core task is to efficiently and accurately convert analog signals into digital signals so that the CPU can process them. This conversion process mainly relies on a high-performance AD converter to ensure the occurrence and speed of the conversion. This model can handle voltage signals within the range of 0 to 10 voltage. The 4 input channels have a common ground potential terminal, and the voltage has a 12-volt resolution. After being digited, the digited state is sent by the coupler to the master device through the bus network. The KL4004 analog output model is specifically designed to convert the digital signal of the CPU into current or voltage signals. It realizes the function through a DA converters, thus enabling precise adjustment or control of the actuator. The KL4004 is a 4-channel analog output terminal model that can generate signals within the range of 0 to 10 voltage. The 4 output channels have a common ground protection terminal, and the voltage has a 12-volt resolution after being digited. The KL9010 bus terminals is necessary for data exchange between the bus coupler and the bus terminal. Each component must be terminated with a KL9010 bus terminal at the right hard end. The bus terminal has no other functions or connections facilities. Next, let's learn about parameters configurations of the back-of DeviceNet I/O. In the previous lesson, we will learn about the setting of the FANUC robot as the master station for DeviceNet master-slave communication. The slave station is the back-of I/O model. The address of this I/O model in the DeviceNet bus is 12, and the corresponding rate number is 82. In the DI configurations interface of the robot side, as shown in the figure, we can see that DI 1 to 16 are 16 digital inputs, corresponding to the 16 digital input channels starting from 9 of the expansion's I/O model. DI 21 to 28 and 8 digital inputs corresponding to the 8 digital input channel starting from 17 of the expansion's I/O model. DI 121 to 128 and 8 digital inputs corresponding to the 8 digital input channels starting from 25 of the expression's I/O model. In the DO configurations interface of the robot side as shown in the figure, we can see that DO 1 to 16 are 16 digital outputs corresponding to the 16 digital output channels starting from 1 of the expansion's I/O model. In the AO configurations interface of the robot side as shown in the figure, we can see that AO 1 to 4 are unnarrowed output channels corresponding to the channels 1 to 4 of the expansion I/O model. After comparing the setting of the DeviceNet network master-slave station and parameters configuration of the DeviceNet I/O model, we can indirectly communicate with the digital sensors, unnarrowed input and output devices of the peripheral equipment through the back-of I/O expression model on the robot side. Okay, everyone, next, let's watch a video. When the rotating platform does not block the sensor, the corresponding input point indicators light on the back-of model is off, and the DI6 on the touch pedestal corresponding to this input point is in the off state. When the rotating platforms rotate and blocks the centers, the corresponding input point indicator light on the back-of model light up, and the DI6 on the touch pedestal is the on state. Everyone, in this lesson, we have learned the basic knowledge and characteristics of the DeviceNet and understood the components of the back-of DeviceNet I/O model, including the bus coupler, digital or analog input and output terminal models, etc. Finally, we configured the DeviceNet I/O model on the robot size and verify its correctness. So this lesson, I believe that you have a systematic understanding of the DeviceNet Bus, laying a foundation for subsequent learning. That's all for this lesson. See you next time.